it's more like I have no idea what I want to work on in my life, but computers are interesting. So I'm taking classes here, and I haven't been pushed away from that. So for now, like my interests and my education like align. A lot of stuff like the research I did over the summer too has to do with computers and distributing like a task a program has to do over the correct piece of hardware, so that it's optimized for speed and stuff. And this is really interesting stuff. And, like, I guess in my own time, I would try to like read up on that if I found it, but like it's funner to take it in a whole level sometimes.
Basically, I have no capacity to work on things that I'm not interested in. So sometimes something like an algorithm will just grab me and I'll spend a lot of time working on it. But other times I'm just not interested at all and I don't do that much. The reasons I take classes are usually just because it looks interesting, not because like I feel like I need to know it. I don't know. I feel like most of the programming I need to know I already know. I've kind of taught it to myself. The stuff I'm learning now is interesting, but I won't really apply it on a day-to-day basis. So.
Actually, how I got started in Linux is I did an internship at a astrophysics lab, and the grad students kind of introduced me to it, and now it's the only thing I use. This semester is actually the first formal training I've had with computers. Everything before that was pretty much self-taught. The internship that I was referring to was actually between sophomore and junior year of high school.
At the very basic level, it's really boring. Once you actually start talking about the interesting stuff, it's interesting.
Curriculum that I've had up to this point within science and engineering, it's very fact-oriented. And there hasn't been a lot of design up to this point. Now, I'm starting to get into that in electrical engineering. Like my microelectronics course, our project is to design an amplifier, and the guidelines to it are it has to filter the signal, the high frequency signal, and then you have to amplify it and with transistors. And that's pretty much all of the framework that he gave us. So that's creative. But
I had never had experience with Maya. I had just experimented on my own with an open source 3D modeling program called Blender. Just really for fun because I thought it was like a cool thing. So I just taught myself how to do that sort of, but never really. I mean, I really like the basic layout. I didn't really have the actual modeling skills. So like, that's the thing. Like on my own, I was able to learn the layout of Blender and be able to do like really basic things. But actually through that class, like now I can do things that I could have never done. I mean, I did a lot of it. I did on my own. Really, what it was just being forced to like work on it for 6 hours a week. And like the structure of the class definitely helped my skills a lot. It's structured in a way that allows for a lot of just kind of like you doing your own thing. So you get as much out of it as you put in, basically. So the professor's there if you want to ask some questions. There's always the internet. You can just kind of Google whatever you need to learn. And I mean that is the structure of the class. It's just like he gives you a project that you learn how to use the software by doing.
Like in the textbook, something's not explained very well. If I don't get that and I don't have like a digital media source, something that I can either interface with the teacher or a vast repository of information like the internet on, then I would be stuck. It's just a very, very valuable resource to have. If you don't understand something that's like even moderately important conceptually on a topic, then everything you learn after that doesn't have as much meaning because if you don't get the base, then everything after that loses its meaning a little bit. You don't have that good of understanding. But with digital media sources, like countless number of times this semester, I emailed my signals and systems professor being like, can I come in and meet with you because I don't really understand this, or like if I'm doing a problem set and I'm looking through my notes and I'm like, I didn't really take as good of notes as I would have liked to for this, then oftentimes like I can go on Telesys and download this like some sort of notes or something like from my math teacher, or I can go on like Wolfram Alpha to check my math, see if I make any computational errors, and it's just a very, very valuable resource to have. And then back to the conceptual questions, if nobody in my immediate vicinity knows the correct answer, or thinks we all know the answer, we can always check it against the internet.
Cool.
And without that near universal access to information, then we wouldn't be able to understand a lot of the I wouldn't be able to understand a lot of the concepts that I've now taken. I definitely learn more in-depth things in a traditional classroom setting because there is a fairly centralized voice, i.e. like the teacher, who is in a lot of, especially in my cases, as an engineer, an expert in the field.
Mm-hmm.
And the internet is more for a supplementary supplementary knowledge. It's something that I probably could email my teacher about, but in the context of things, I would hear back maybe like in a couple hours, maybe like the next day or two, and that's it. That's not fast enough anymore.
But also, it made it so much easier to, like, a lot of times I'd like look something up on the internet or try to do things on my own, and sometimes you can. Sometimes like it's very difficult to find answers to specific problems to your specific project. So having a professor was very useful for that.